Let's understand Grignard reagent in depth. Now, initially, how do we synthesize Grignard reagent? We use magnesium wire or turnings, clean and dry, and use dry ether as solvent, and is reacted with alkyl or aryl halide to get RMGAX. R alkyl group, X is the halide, and Mg is there. Alright, so this is what is Grignard reagent. Now let's see what Grignard does to ketone. Now we have taken ketone here. H means it can react with ketone as well as aldehyde. If R is H, then it's an aldehyde. If R is R, then it's a ketone. Alright, so simultaneously I'm trying to show aldehyde and ketone reaction. So right now don't focus into this. Later on you can just assume R to be H, and same reaction you can carry on with aldehyde also. Okay, alright, so whenever two bonds, one is sigma, one is pi bond. Now whenever we talk in terms of R prime, MgX, R has delta negative charge and MgX has delta positive charge. Now this acts as a nucleophile, nucleus loving, so one which it wants to attack to positive cations. Alright, now here in this case, oxygen being more electronegative pulls electron density towards itself, thus acquires delta negative, and this carbon acquires delta positive. So best condition for nucleophilic attack. This is already delta negative, so this does a nucleophilic attack on this carbon of carbonyl, and what happens? So it's doing the nucleophilic attack on this C plus, and the pi bond which is there moves up, so this becomes negative. All right, so basically R prime does a nucleophilic attack on this carbon of carbonyl, pi bond shifts over this, so this is what happens. So R prime get attacking here, doing a nucleophilic attack, and this going here, and this attacking Mg plus, MgX plus. Alright, so what happens is we get this intermediate R prime attached, COMgX, and this R again, repeat that this in place of H, in place of R, it could be H also. Alright, so this is what happens. We call this as an adduct. Absolutely unstable, so we put it into bracket. Then what happens in step 2? In acidic medium, the reaction occurs. So in acidic medium, now what happens is hydrolysis occurs. So water gets split up into OH minus and H plus. O minus does nucleophilic attack on this carbon, and this shifts over here to oxygen, and that O minus attacks on H plus. Alright, as a result of that, what happens is this becomes MgXOH, that is this, and this OH comes over here, so we get this here. So R prime got fitted earlier itself in adduct, OH got fitted right now from water in acidic medium via hydrolysis. Alright, so what we end up is 3-degree alcohol. Now if that R would have, this R, it would have been H, then we would end up with secondary alcohol. So if we start with a ketone, we end up with a tertiary alcohol, and if we start with aldehyde, then we end up with secondary alcohol. So we can synthesize tertiary or secondary alcohol depending on what starting material we have chosen, whether it's a ketone or an aldehyde. Alright, so that's how we synthesize. Grignard reagent works. Now Grignard reagent we can also do it with carbon dioxide. Carbon dioxide is dry ice. Now Grignard carbon dioxide, now we are aware with, this is delta minus, this is delta plus, so R minus would attack on this carbon. So we, as I told you, if there are two bonds, one bond is sigma, rest whatever bonds are there, if it is triple bond, then one bond is sigma and other two are pi, and here we have double bond, so one is sigma and the other one is pi. Okay, so it does attack on that. Pi bond moves over oxygen, generating O minus, that O minus attacks Mg plus. Alright, so we end up with R C double bond O. This is C double bond O. This R is which it has got attached, and pi bond shifts over here, gives its own negative charge, and that does a nucleophilic attack on Mg, and we get OMgx. So this is the intermediate that we get. And then what we do is acid hydrolysis. On acid hydrolysis, again what happens? O minus, it is H plus hydrolysis, means breaking of water into OH minus and H plus. So OH minus does a nucleophilic attack on the carbon of carbonyl, and this shifts over O minus, which attacks H of water, H plus of water. Alright, so this becomes MgXOH, and this becomes R C double bond O OH, R C double bond O OH, carboxylic acid. So from dry ice, using Grignard reagent, we can generate carboxylic acid. R obviously is the alkyl group. Okay, let's understand what Grignard does to methyl cyanide. This compound, by the way, has three names. This is called as acetonitrile, methyl cyanide, or ethane nitrile. Okay, let's understand what Grignard does to methyl cyanide or acetonitrile. Of course, in presence of all this reaction that we did was in dry ether. Alright, because it's very sensitive to moisture. So what happens is R minus does a nucleophilic attack here. I told you that if there are three bonds, two of them are pi and one is sigma. So one pi bond shifts over nitrogen, gives it negative charge, and does a nucleophilic attack with Mgx. Alright, so what R gets attached to carbon, and double bond, triple bond gets converted to double bond, and nitrogen gets attached to Mgx. So this is the intermediate that we get, and C double bond N is known as imine, absolutely unstable intermediate. Alright, now acidic. In case of acid hydrolysis, what happens is OH minus and H plus, water, hydrolyzed. Alright, broken into lysis is breaking of water, OH minus and H plus. OH does nucleophilic attack on carbon, pi bond, another pi bond is there, so that shifts over nitrogen, then that gets negative charge, that negative then picks up this hydrogen, thus forming NH, Mgx, and this OH gets attached to it. Now OH gets attached to it, so then what happens is this bond which is there shifts over carbon, and this bond shifts over nitrogen, and that, so nitrogen gets negative charge, so that picks up this hydrogen. Alright, so cycle. Now this goes there, converting this into carbonyl. Then now if it is converted into carbonyl, then it has got 1, 2, 3, 4, 5 bonds, so not stable. So this bond again moves over to nitrogen, nitrogen becomes negative, that picks up hydrogen. Alright, so this cycle goes on. So as a result of that, we end up with CH3C double bond O R with a ketone. So when we start with nitrile, we end up with a ketone, and the reaction is not yet over. Now we have got this NH2 Mgx there. Again further hydrolysis occurs, N2 picks up hydrogen, forms stable ammonia, and OH attacks here to form Mgx. To form MgXOH. So basically OH minus attacks to this Mg, this bond goes to nitrogen, the nitrogen becomes negative, that nitrogen negative attacks H plus, so this forms ammonia, and this forms MgXOH. Okay, alright, so that's how the reaction occurs. So basically what we saw is that when we use cyanide, we end up with a ketone. When we use carbon dioxide, we end up with an acid. And when we use a ketone or an aldehyde, we end up with tertiary alcohol or secondary alcohol. Alright?